Let's have a look at an example where we need to not only solve simultaneous equations graphically, but we need to actually write the equations in the first place. So, in this example, we have the perimeter of a rectangular photo is 50 centimetres. Now, if it helps you to draw something first, let's just draw a rectangle and then label it. Here we've got use L for length and W for width. So let's put that on our picture, W and L. All right, we know the perimeter is 50 centimetres. So part A says use the length and width to write an equation for perimeter. All right, how do you find perimeter? Add up all the sides, right? So there's a couple of ways you can do that. You can go W plus W, that's 2W, and length plus length, that's 2 lots of L, that's 2L. And when you add all of those up, you get 50 centimetres. Let's just say 50, okay? Now, somebody else might have said, hold on a minute, my way of finding perimeter is to add W and L together and then double it. So they might have said we want 2 lots of W plus L. And that's going to equal 50. Okay, now does it matter? Not at all. This is just a factorised version of that. Okay, now the person who's done it this way might quite easily spot that they can simplify this if they want to. Okay, if you halve this side, you just get 1 lot of W plus L. But you've got to halve this side to make up for it, right? So you've got this, okay? Now you can do the same thing with this equation. You just got to remember to halve all 3 things in the equation. So you get W plus L equals 25. So this one is the best equation here for part A. And that's the one we're going to stick with. Now, would it matter if you kept it like this? No, not really. You could still work with that. This is just a simpler form of it, okay? All right, part B, write an equation to link L and W if the length is 5 centimetres longer than the width. Okay, so if the length, let's do part B over here. If the length is, that's equals, 5 centimetres longer than the width, that means the width is the short one, right? So if you take the width, you have to add 5 for it to equal the length. Now, I might be kind of going slowly and carefully here, but I'm doing that on purpose. This sort of thing looks so simple, it's really easy to just race ahead, read that, and then jot something down quickly, and you could accidentally end up with these around the wrong way. So think it through, write it down, then read the sentence again, and then think which is the long one, the length. So that's the big one, so the short one has to have something added to it, and just kind of check it makes sense, because it's super common in something like that to mix those 2 up. All right, so we've got this as one of our equations. We've got one here, we've got another one here. Okay, that'll do. All right, part C says solve these equations graphically and find the photo's dimensions. We need to draw up a little table of values. Now, you're used to working with X's and Y's. Here we're working with W's and L's. Does it matter? No. You just need to make sure that you label the axes that you're going to draw these on. Let's have W being down here on the X-axis, and L can be up here on what we'd normally call the Y-axis. Okay, now what points should you choose for W and L? And how many should you choose? Well, around about 3 is enough just to make sure they are actually all in a straight line. Instead of going 0, 1, 2 here though, I'm actually just having a look and seeing that the 2 things have to add to 25. So if I did 0, 1 and 2, I'd have 25, 24, 23, wouldn't I? And if you've got 3 points that are really close together and then you've got to try and draw a big long line and see where an intersection is, it might be better if your points was further away from each other, so then your line will be a little bit more accurate, okay? So I'm thinking it'd be good to know where it crosses the axis of both things. So let's think if W is 0, then L would have to be 25, wouldn't it? And if L is 0, then W would have to be 25. Now that's 2 really easy points to find. And let's just give it a point somewhere in between. If W is, say, 10, then L would be 15, because they have to add to 25. Okay, we could go ahead and plot this line now. When W is 0, L is 25. And when W is 25, L is 0. So it's like this. And you're going to have a line with a gradient of -1. How do I know it's -1? Well, this is 25 and this is 25. So it loses 1 for every one that it goes across, doesn't it, in the way of boxes. Okay, so we've graphed that line. Let's do a table of values now to graph the other line. We're going to use 3 values. Now what should we use? Well, this one's a little bit different. L equals W plus 5. Let's just go with something straightforward like 0, 1, 2 and see how it looks. If W is 0, 0 plus 5 is 5. If W is 1, 1 plus 5 is 6. If W is 2, 2 plus 5, 7. Okay, so if I look at how to graph this, I've got the point 0, 5, which is going to be around about here, and then 1, 6, 2, 7. Okay, it's going up like that. Now, if I've only made 3 points, can you see here, I'm nowhere near the intersection? So it might be nice to graph an actual point that I know is going to be pretty close to where this one is. So I'm going to do one more point here. What if W is, say, 10? All right, well, if W is 10, 10 plus 5 is 15. And that's actually a point that I graphed already earlier, okay? Now, I sort of had a bit of a potluck guess that would be around about there. So I've got the point here, 10, 15. Now, graphing that line, it comes up like this, okay? Now, did I have to have 2 points actually worked out with a table of values to make this happen? No, if you've got lovely graph paper, both of these lines have got a gradient of 1 or minus 1. So the line is going to go up through all of the little crosshairs on your grid book. So even if I didn't have that exact point on both of those, I would still be able to find this as my solution. Okay, so what is the solution? Well, the solution is, therefore, W equals 10 and L equals 15. Now refer back to the question. It says find the photo's dimensions. All right, well, width is 10 and length is 15. So go ahead and actually write that. Now, why do you need to write that? Well, if you solve an equation and it's got W's and L's and things like that in there, that's all well and good. You've done some maths, right? But this person wants an answer that's in plain English. It wants to know how wide the photo is and how long the photo is. So you have to go the extra mile, especially in an HSC question, and actually say, therefore, the width is 10, and then put units on it. We know these are centimetres, width is 10 centimetres, and length is 15 centimetres. Now, what should I do when I get to here before I move on to the next question and just be really sure I'm finished? Well, I would think it's smart to just do a quick double check that things add up. 10 plus 15 is 25, and 25 plus the other 25, that'll give me a perimeter of 50. So I just did a quick mental check there to make sure that my maths was good and the answer that I got actually made sense.